Hey folks, welcome back. In this video we're going to look at light emitting diodes, also known as LEDs. So let's get into it. So what are LEDs? Well, we say that LEDs or light emitting diodes are forward biased PN junction diodes that emit photons. So we've already seen in a previous video what forward biasing means for PN junction diodes, and we're saying that these are ones that emit photons, i.e. particles of light. So here's an inside view of what an LED looks like. You've got these terminal pins here on the outside. You've then got a transparent plastic case which will have a certain colour, in this case it's red, and we've then got our PN junction diode, or two layers of materials, P-type and N-type materials, and then we've got the emitted light coming out here. And there's the circuit symbol for an LED, which you might remember from National 5 Physics. So we've got our kind of triangle shape with the straight line on the end, and then we've got our two arrows going out from that showing you that light is being emitted. So how do LEDs actually emit light? Well, this is a very common exam question for you to be asked, where they might ask you to explain using band theory how LEDs work. So here it says that when a battery is connected to an LED in forward bias mode, electrons in the conduction band of the N-type now have enough energy to overcome the potential difference across the junction and move towards the conduction band in the P-type. So if we look at this picture here, we're saying that these electrons in the conduction band of the N-type material now have enough energy due to the potential difference or voltage from the battery to move across the junction into the conduction band of the P-type material. And similarly, it says the holes in the valence band of the P-type move towards the valence band in the N-type. So we're saying that these holes in the valence band of the P-type material now have enough energy to move across the junction into the valence band of the N-type material. And then it says that when close, electrons can fall into holes. This means that they drop energy level from the conduction band to the valence band, otherwise known as recombination. When this occurs, energy is released in the form of light, i.e. photons. So in the middle region here in the junction, when we get electrons and holes that are close, these electrons can drop down in energy from the conduction band to the valence band, and when the electrons fill the holes, we get what is called recombination, where light is then emitted. It then says that light can escape because the junction is very near the surface of the material. The wavelength and therefore colour of the light produced by the LED will depend on the energy loss of the electron. The greater the energy loss of the electron, the higher the frequency of the light emitted. So just to show you a couple of simulations to help you understand this, let's say we've got our PN junction diodes connected in forward bias mode to make an LED. So we've got our P-type material connected to the positive terminal of the battery and our N-type material connected to the negative terminal of the battery. If I close the switch here, because it's in forward bias mode, remember this is essentially going to remove the electric field here or reduce the width of the depletion layer. And then what's going to happen is when electrons and holes recombine at the junction, we get recombination occurring. So it says that holes and electrons recombine to give out quanta of radiation known as photons. So this is our light. And this is going to happen every time an electron recombines with a hole. And I can make this go continuously to show you how light is continuously produced in an LED. So you'll see the green waves being emitted here. That is essentially our light, our little packets of photons. So here's a slightly different view of the LED, showing you the P-type and N-type materials as a sort of sandwich there with the depletion layer between them. So that's the junction there. And you should also note down here that it says an LED is a PN junction diode. LEDs are based on gallium instead of silicon. So although we talked about silicon a lot for P-type and N-type doping, gallium tends to be used for LEDs. So if I close the switch here, you'll notice that we get an electron and hole recombining there to emit light at the depletion layer or at the junction. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.